Hello, good morning my warriors. Welcome aboard. This is Shreyas here, your master teacher for physics at Vedantu going live. Hello, sorry for that small delay. Welcome, good morning. Nice to see all my minions. Nice to see all my warriors ready to battle it out early in the morning. Hi Surya, hi Sakshi, hi Hasib, hi Priyanka, hi Shreyas. Hello Ankit, hello Gayatri, hello Gopal, hello Vanaprati. Welcome aboard. Thank you guys for all the love and all the support that you show. Hello Aditi, good morning. How is everyone? Yes, let's rock it. Let's do the topic of thermodynamics. Very important. So guys, it's only because of your comments I'm taking up this topic. Lot of you people commented that sir, we want thermodynamics. Sir, we want this topic. So that's why I have taken it up. And just for your benefit, I have divided thermo into two parts. Today we are just going to do thermal physics, calorimeter, thermal expansion, and we are going to do heat transfer. So heat transfer, thermal physics like the expansion part and temperature scales, and calorimeter. The next time I will be doing this, I will be doing KTG, kinetic theory of gases, specific heat capacities, and the laws of thermodynamics along with heat engines and refrigeration. So I have divided it into two parts. Hi Sai Sashank, you are now pulling go. Okay, thank you. Okay, so Pradyumna Sriram, how about this? Why not comment below in the comment section after the session ends? I will reply to all the comments. You would have seen in my past videos also I reply to all the comments, or you can contact me on Shreyas_Vedantu. Gopal, I'm doing much better. Thank you very much. Yes, Eid is tomorrow, so I'll say Eid Mubarak maybe tomorrow. Gayatri, my health is much better now. Thank you so much. Okay, yes, let's rock it. And this is the schedule for this week, by the way. In case many of you probably have missed some of the classes, this is the schedule. This is the 2022 class, like the 12th standard batch. Okay, plate and shell problems. Then I had a special session for all the 2021 aspirants on the JEE Advanced test. Batch, which is called as the EKLAVYA. Then units and dimensions, that's for 11th standard. Menti quiz we had yesterday for 12th standard as well as the 2021 aspirants. Today we have the 0 to hero in thermo. Tonight mock test. Yes, tonight mock test at 7:30, and tomorrow 11th standard topic 2023 aspirants, and a special guest on Saturday at 7:30. All right, so get ready for this session. Any guesses what this session could be? Let me know in the chat box running out there. Yes, and what do you guys think this special session is going to be about? I'm going to come up with a lot of special sessions for all of you. Hello Karthik. Yes, there are some questions on graphs also, and also Karthik, tonight I have one very special problem in mock test. Attend that mock test, you will see some amazing questions. Every time in mock test I come up with a lot of questions from all the topics. Hi, good morning Chaitanya. Yes, let's get going. And by the way, let me also tell you guys, because probably the next JEE Mains attempt is going to be the last attempt, so you have to buck up. Anytime the announcement might happen. The COVID cases are falling down now slowly. The peak has been reached. So I am guessing in the next few weeks, the announcement for the JEE Mains examination dates will come up. I know the dil is doing dhak 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 dhak. Your heart is beating faster because I know you all want to write the JEE Mains. You want to write BitSat, you want to write VIT EEE, you want to prepare for JEE Advanced, and you want to get a seat for sure in the NITs or other government colleges, so that you know for sure you're going to a college this year. So guys, I know you want a branch of your choice, you want a college of your choice. This is the last few weeks of your preparation, and the 2-year preparation for your JEE, for all your competitive examinations, is going to come to an end very soon. So hold on there. We are about to reach it, but we need to make sure that our preparation is up to the mark. So in case you want to give in your last final effort, everything that you have done for the last 2 years, but you want to push yourself to the extreme limits, And the reason why I'm telling you about all of this is because, you know, we have been producing a lot of toppers over the past few years, like you can see on your screens. A lot of the people who were there in some other institute, after joining with under the guidance of our master teachers and with our systems, with our methodologies, they have improved a lot. Like you can see, you know, these are the percentiles, 99.97 percentile and all that. In fact, if you compare the other students from non-Vedantu and Vedantu students, you can see the performance is always better. Like you can take the comparison of CBSE examinations. Outside students score who score 90%, all right, it's around 13%, but Vedantu students, 69% of Vedantu students score 90% and above in CBSE examination. So these results just show what we do, and I really hope that you take our guidance, our mentorship and our test series and our assignments and our systems, our methodologies for the last few weeks. So guys, there is a crash course running which has just started on Monday, so please check it out. It's there in the description box below, the link. Join using the link and make sure you use the coupon code SHCC for availing maximum discount. The reason why I'm telling you to join the crash course is because everything like classes, assignments, test series, notes, replays, doubt solving will be included in the crash course for JEE Mains. It has just started yesterday and it will get over by June first week. So it's just a 1 month crash course. 11th and 12th standard syllabus completely will be done in this crash course by our amazing master teachers. So go ahead and check it out. Now let's get going to the thermodynamics part. First we are starting with thermal expansion. Hello Snehal, welcome aboard. Gopal, VIT is a good college, but I think you should aim for NIT and other government colleges, not for VIT first. VIT is in the last ditch effort if you do not get any of the good government colleges. Okay. Now, first of all, you should know the conversion factor between Celsius and Fahrenheit. So if you know the temperature in Celsius, multiply it by 9/5 and add 32, you will get in Fahrenheit. Example, 0 degrees Celsius. So if Celsius is 0, then Fahrenheit will be 32 degree Fahrenheit. So 32 degree Fahrenheit is 0 degree Celsius, which is a melting point of ice. Kelvin to Celsius, that's the standard. So if you know anything in Celsius, just add 273, you will get it in Kelvin. That's pretty much a standard. Hi Sai Charan, good morning. Okay. Yes, let's battle it, Vikram. Okay, you're battle ready, very good. Okay, now the next thing that you should know is for expansion, final length is initial length into 1 plus alpha delta T. And similarly, if you have an area which expands, final area is initial area into 1 plus beta delta T, and final volume, if you have a volume which expands, is initial volume into 1 plus gamma delta T. Delta T is temperature change. This alpha, beta and gamma, they are called the coefficients of thermal expansion. This is coefficient of linear expansion. This is coefficient of areal expansion. This is coefficient of volume expansion. It will be given to you just like coefficient of friction or density or any other property of material. This is a property of material, this alpha, beta and gamma. Keep this in mind. Now, there is a relationship between all of them and it's very easy to remember it. Gamma, volume expansion coefficient, is 3 times of alpha. Just remember that. Volume is length, breadth, height, right? So 3 times of alpha. That's one thing. Area is length into breadth. So 2 times. So beta is 2 times of alpha. So you should know that. Beta is 2 times of alpha and gamma is 3 times of alpha. Okay. Last thing. If you take a rod and you clamp it between 2 walls. Hello Raja Raman, welcome. Yes, imagine if there is a rod and if there are 2 walls and you clamp it and you heat it. So the rod would like to expand, but it can't expand because it is under, that compressive force by the clamping walls. So there will be some stress which will be developed inside that rod. That stress is called as the thermal stress, and the formula for stress, remember stress is force by area, Newton per meter square, is Young's modulus into linear coefficient into delta T. This is the formula. Keep this in mind. Are you guys now ready for solving some problems? This is your important slide. All the important formulas are out here. Are you guys now ready to start solving some problems? Let me know in the chat box. And if you guys are ready, yes, also hit the like button. In case you have forgotten to hit the like button, do not forget to smash that like button. And all the new warriors, do not forget to hit the subscribe button down there. And remember, the entire formula sheet will be available to you in the Telegram group. The link for the Telegram group is there in the description box below. Okay, so I hope you have hit the like button and the subscribe button and join the Telegram group as well. So let's get going. And there it comes, the first question up on your screen now. There we go. Yes. Come on, let's see. Okay, which of the following statements is true for a thermometer? Come on, which of the following is true for thermometer? Come on, let's see. Come on. Coefficient of cubical expansion of liquid is more than that of the bulb. Coefficient of cubical expansion or volume expansion of liquid is equal, or is it less, or none of the above? Come on, think about it. Yo, everybody is ready. KM Singh, Snehal, Gayatri, Ankit, Shreyas, Vijay Kumar, Pradyumna, Jules, very good. Vanaprathi, Soumya, Janat. Yes, all of you are ready. Some of you are saying B, some of you are saying A. Hello Soumya, good morning. Well, Rishi, hello, welcome Rishi, join in. Anipur saying B, Priyanka saying A. Guys, see, when you have a thermometer, see, even the bulb or the glass will expand, even the liquid will expand. Now just think about it. How do you measure the temperature? You will see that there is some red liquid inside and it goes up and down if you have seen the thermometer. Why does it go up and down? Because the liquid expands. Now just think about it. The glass itself will expand more. Then what will happen? That's meaningless. That's meaningless. If glass expands more than the liquid, then even if you heat it, just imagine you heat it, you know, the glass has expanded more than the liquid, so actually the level will go down and you will be like, oh, the temperature has fallen down. So that does not make sense. So guys, understand, the liquid should always expand more than the glass, so that when you heat it, even if the glass expands, even if the bulb expands a little bit, it's okay, but the liquid should expand more and the reading will actually go up. Else, that will create a lot of confusion in the heads. If it is equal, then what will happen? If you heat it, the glass expands as much as the liquid expands, and you will see there will be no rise in the level of the liquid and there will be no change in the marking on that thermometer. It will be constant. And one will think, oh, the temperature hasn't changed. So understand that the liquid should expand more than the bulb of the material of the thermometer. So answer is A. Yes, it is A option. Beautiful. Good morning. Anything awesome? Welcome aboard. Everybody clear with this? So the bulb should have less coefficient. The liquid should have more coefficient so that you get the proper reading. Anything else will give you a wrong answer. Okay, let's see the next question coming up on your screen. Beautiful, it's clear. It's, yes, very good, understood. Two rods of lengths L1 and L2 are made of materials whose coefficients are alpha 1 and alpha 2. Two rods L1 and L2, different materials, alpha 1, alpha 2. If the difference between the two lengths, okay, when you heat it and when it is cooler, the difference between the two lengths is independent of the temperature. It's independent of the temperature, then which is the correct relationship between them? Come on guys, figure out what should be the correct answer. Mark the correct answer, solve it. Without solving, you will not get the correct answer. Come on all my warriors, some of you are saying C, some of you are saying B. Hello Trimbakam, welcome aboard. If the difference between the two lengths, when you heat it and when you cool it, the change in the length is independent of the temperature, then which of the following relationship holds true? Come on. Yes. So Karthik Reddy, please watch the video which I have posted few days back. I have conducted a session with Vikas sir. Watch the video, all the details are mentioned in that video. Or post a comment after the video ends. I won't be able to answer the question right now because I don't want to break the flow of the questions. Okay. Now the funda is the change in the lengths, the difference between the final length and initial length is same. So delta L1 is delta L2. Now what is delta L1? Remember, I just gave you the formula. Change in length is alpha delta T. Original length into alpha delta T. So L1 alpha delta T, okay, will be equal to L2 alpha 2, okay, delta T. Delta T is same for both. Delta T is same for both. So it will get cancelled from both sides. And what will you get, guys? L1 by L2 will be equal to, think about it, L2 comes down, L1 is on the top, alpha 1 goes below, so alpha 2 by alpha 1, which is nothing but option B. Yes, option B is correct. A lot of you got the wrong answer. Only few of them got the correct answer. Ask me, bacha, where were you yesterday? Day before yesterday, you were not there in the 11th standard class. Abhi tumhara kaan pakadna padega. Ask me. Okay, so that's the correct answer. Option B is correct. Yep, very good. Anything awesome? Excelente, clearo. Let's go to the next question. Now don't get scared by the length of the question. Trust me, it is a very easy question. Observe, read, draw the diagram. There are two rods, different materials. Coefficients are alpha 1 and alpha 2. So two rods. One rod has alpha 1, second rod has alpha 2. Young's modulus is also different, obviously. Two different rods, Y1 and Y2. Okay. Now they are fixed between two walls. They are clamped between two walls. The rods are heated. So you heat the rods such that, you know, their temperature change is also same. Their temperature change. Obviously, you heat both the rods by the same change in temperature. Now, if alpha 1 by alpha 2 is 2:3, the ratio is given. Alpha 1 and alpha 2 is 2:3. It's given that the thermal stress is equal. The thermal stress in both the rods. Remember, the rods will be under stress because they want to expand. They want to expand, but they cannot expand, so there is stress. If the stress is same, then what is the ratio of the Young's modulus? That's the question. Alpha's ratio is given. Write the formula, visualize the situation, write it. Within 2 steps, you'll get the answer. Come on, come on, come on. Think about it. I just given you the formula. Oh, Asmi, okay. You have already joined the pro subscription. So that's why the classes are clashing. Okay, no problem. Okay, fine. As long as you are attending the pro subscription wave classes, no problem. I hope you are enjoying the pro subscription, Asmi. Okay, D is the answer. Jules said D. JLP says C. Okay, come on. Think carefully. Think carefully. Okay. Akansha Bag says D. Okay. Yo, very good. Okay. Rishi says D. Aditi also saying D. Y is inversely proportional to alpha. I don't know. Let's figure it out. Okay, so let's see what's the formula going to be. Read the question carefully. You will see that the thermal stress are equal. This is the key word. Thermal stress is equal. What is the formula for thermal stress? Sigma, all right, I just given you, is Y alpha delta T. This is the formula. It's also given same increase in temperature. That means delta T is same, sigma is also same. That means only these two are different. If these two are different, their product is constant. That means Y is inversely proportional to alpha. Young's modulus is inversely proportional to alpha. So that means Y1 by Y2 will be alpha 2 by alpha 1. Now what is alpha 1 by alpha 2? It is 2:3. So alpha 2 by alpha 1 will be 3:2. That's it. Within 2 to 3 steps you get the answer. So 3:2, guys. That is option D. Option D. I hope this is clear. That's how you need to do it. Looks lengthy, but these kind of questions will unnecessarily spoil the mood of a lot of students. They will get scared. Oh my God, such a big question. What the hell is happening? I don't know how to solve this. And they will leave that question. But if you have patience, if you have a cool mind, and if you do not get nervous in the examination, you will not leave these questions and you will get the marks easily. So +4 marks guaranteed, and your rank will be boosted by at least 5 to 700 ranks at least, depending on where you are. Next question coming up on your screen. Okay. Delta T means change in temperature, Vijay Kumar. Okay. Yes. Yes. Anything awesome? That was correct. What you said. Okay. An external pressure P is applied on a cube at 0 degrees Celsius so that it compresses from all the sides. So when you apply pressure, what happens? Anything will shrink. It compresses. Okay. K is the bulk modulus of the material. Alpha is the coefficient of linear expansion. Linear expansion. Now what we want to do is, because we have compressed it, I want to bring back that cube to the original volume. I compressed it by external pressure, I want to bring it back. How? By increasing the temperature. How much should be the increase in the temperature is the question. How much is the increase in the temperature? Don't worry anything, probably you'll love it after this question. Come on guys. Okay, yes, Vijay Kumar. Glad all the minions, all the warriors are helping each other. Oh, Akansha, don't worry, even if you are in 12th, you would have definitely learned this topic of thermal physics, or maybe it was done at the beginning of 12th, so you will be able to answer this question. How to start this question? Okay, there are two concepts, Aishwarya. One is solids elasticity, that chapter. Second is volume expansion. You need both the concepts together. See which term is common in both of them. And I think it's the change in the volume which is common in both of them. So come on guys, think about it and try to do that. No problem, Vijay Kumar. Okay, some of you are saying C, some of you are saying A. Think carefully. Two chapters combined together, solids expansion, elasticity and the thermal expansion, combine it together, see which is the term which is common in both of them. So first of all, think guys, okay, when you apply external pressure to the cube so that it shrinks, so that it shrinks, let's use, the bulk modulus formula. So, solids volume change formula. Okay, what is the formula? Bulk modulus. What is the bulk modulus? K is equal to applied pressure, extra pressure, P, divided by the strain. What is the strain? Change in volume upon original volume. This is the formula. If you remember, bulk modulus is bulk stress upon bulk strain. Young's modulus is longitudinal stress by longitudinal strain. Same way, shear modulus is shear stress by shear strain. So this is what you get. Okay, but do I know this? Nope, I do not know that. I do not know that. Yes, Priyanka, maybe it will help you eliminate few options, but you never know, right? Maybe two options are same, so I'm just showing you the method. Yes, by units also you can solve it, but it might take you some time. I think it is not that difficult that you would probably go for units. Now the second concept that you should use is, you are heating it. So when you heat, all right, that will lead to volume, okay, expansion. And what is the formula for that? Change in the volume is original volume into gamma into delta T. This is the formula. Now you can clearly see delta V is over here and here. So I need to do something, but before that, here is what I will do. Delta V by V, okay, I just bring that volume over here. I just brought that RHS term over here. Oh, there is gamma, but I need to convert it into alpha. Read this carefully. Alpha is given. How many times of alpha is gamma? How many times of how many times of alpha is gamma? Volume and linear. 3 times. Think about it. Yes. So hence, guys, this will be nothing but 3 alpha into delta T. Yes. So what you need to do is take this term and shift it over here. Bring it over here. And let's see what do we get. So what we get is basically P divided by 3 alpha delta T. This is nothing but K. Yes, this is nothing but K. But the question was find delta T. So delta T will be P by 3 alpha by K. So K will go there. So which is the correct option? I think this is the correct option. Yes, that's how you solve this question. It's not that difficult. There are 2 chapters combined together. These kind of questions, combination of concepts can also come in JEE Mains. So you need to be prepared for that, and that's what we are doing in this Zero to Hero series. Okay, if you have loved the way I have solved this, do not forget to hit the like button as well. And if you do not want to miss any of the further classes, do not forget to hit the subscribe button also down there. Okay, so let's get going to the next one. How you approach the questions, Ankit? Try to understand it part by part. Try to understand what are the concepts involved, because the question involved pressure, compression. So I immediately remembered it will involve elasticity, because the question said temperature has to be increased and you want to increase the volume, that means volume expansion. So 2 chapters are there. Then try to figure out and remember which formulas relate these two concepts, and then see which are the terms which are common. I saw delta V by V is common, so try to use mathematics to relate the two. So that's how you approach the problems. Okay, let's get going. Yes, let's get going. And yep, so yeah, let's go to the next question. Okay, now before going to the next question, I would like to give you the next set of formulas for calorimeter. So we are going to calorimeter questions also now. Remember, the principle of calorimetry says whenever you have an insulated box, nothing can come inside, nothing can go outside. In those situations, what will happen? The hotter bodies will become cooler, the colder bodies will become hotter. That's what will happen. Now, in this process, the heat which is lost by the hot bodies will be the heat which will be gained by the cold bodies. This is the principle that you have to stick to throughout the chapter of calorimeter. They will give you 2 liquids are mixed, or ice is put in water, or you take a metal and you put it in something else. One will become hot, one will become cold. Find the final temperature or find the specific heat. So these kind of questions need this principle. Next thing that you should know is this formula. Q is ml. When will you use this formula? This is heat, this is mass, this is latent heat. That is joules per kg or calories per gram. The amount of heat required to melt, to vaporize, to solidify, to condense any object is called as the latent heat. Like, for example, let's see how many of you remember this value. What is the latent heat for converting ice into water? Do you remember that value? What is the latent heat for converting ice into water? No, Arul, it is not enough. And to answer your query completely, Arul, post your query in the comment section after the video ends. I will answer it. Akansha, the test in the crash course happens every week. In fact, as you reach towards the end, you can give more tests, and you have the choice and the flexibility to give the test as per your time and as per your convenience. The discussions are also available, the solutions are also available, the analysis is also available. Your report card will get generated after you give the test. Okay. No, it is not 540. A lot of you got it wrong. Yes, it is 80, guys. It is 80 calories per gram. 80 calories per gram. Forgot. I think you have forgotten it. The latent heat for converting water into vapor, that value, yes, that value is 540 calories per gram. Yes, that value is 540. Yes, a lot of you get confused between the two. A lot of you get confused. Be careful, okay? So this is the value. So that means you need 540 calories of energy for 1 gram of water to convert it into steam. Similarly, if you suck away 540 calories from steam, then you will get back water. It will condense into water per gram. This is what it is. And last thing which you should know, MC delta T. When you take any solid, liquid or gas, you heat it. If the phase is not transforming, then the temperature will change. See, water from 0 to 100, temperature changes. At 100, you will use this formula. At 0, you will use this formula. So, when the phase is not changing, you will use this formula, MC delta T. C is called as the specific heat capacity. What is the specific heat capacity for water? What is the specific heat capacity for water? Come on, guys, answer the question. Come on, think. Try and recollect. What is the specific heat capacity for water? Let's see whether all you warriors remember that formula, remember that value or not. No, it is not 0.5, Aishwarya. Try and recollect. Joules quote, yes, says 1. Very good. Yes, Nehal, it is 1 calories. You should remember the unit also. Calories per gram per degree Celsius. This is the answer. No, Palak, 540 was latent heat. Latent heat for converting water into steam. 540 calories per gram, that was water. Write it down 100 times. Write it down 100 times in your books. Yep. And how much is 1 calorie, guys? How much is 1 calorie? Try and recollect. It is, yes, 4.2 2 joules. This is the conversion factor, you should know that. No problem, Rakesh, join in. Welcome, good morning. Yeah, no problem, happens, Palak, don't worry. Nobody is angry at you, nobody is going to judge you. We are all coming over here to learn. Make 100 mistakes. Guys, even if you make all mistakes now, it's okay. But if you learn from it, and if your marks get boosted by 20 marks, 30 marks, trust me, I'll be very happy, because you know that's what is the aim of the Zero to Hero series and the mock test and all the sessions we conduct here. I am pretty sure just by attending these sessions, your score will get boosted by 20-30 marks. And this has happened in the previous sessions when I conducted, you know, all the mock tests, etc. for the February-March attempt. Students messaged me and told, sir, my marks got increased by 40 marks, 60 marks, sir, sometimes 30 marks. So this was the improvement, and I'm pretty sure you will also say the same thing for the next attempt. Let's get going with the next question coming up on your screen. Yes. So is this helpful for 2022? Yes. Yes, Gundira. Yes, Gundira Buchurelli. Yes. A steel ball of this much mass falls from some height, bounces but to a lesser height. Now because it bounces to a lesser height, think what will happen? Something has happened over there. Okay. Now if the dissipated means lost energy, is absorbed by the ball itself, how much will be the increase in the temperature of that ball? Let's see whether you can do the calculations really quick. Thank you, Jules Code. That's the aim. Okay, come on. Come on, think about it. HC Verma is not good. And Arul, please don't spam, bacha, don't disturb others. Understand, I will reply to your comment after the video ends in the comment section. Post a comment. Have that much patience and maintain that discipline. Okay? Come on. Prahlad says B. Yes, come on. Think about it. Just write the equation. Aditi says B. Ball drops, loses some energy, some amount of energy is lost. That energy gets converted into heat. So how much is the increase in the temperature of the steel? Let's do this. Can I say the energy which is lost, okay, is equal to, you know, the heat which is gained by the steel ball? And this is basically the potential energy which is lost. Because earlier it was dropped from 10 meters, now it is only able to reach 5.4 meters. Clearly there is a loss in that energy. That will be gain in the heat. Okay, how much is the potential energy lost? mg delta h, the height difference. The height difference between this and this. We are going to do that in the next step. What is the heat gained? mc delta t. Now the best part is that the mass value is not even needed. It gets cancelled out. So that's the best part. Now what is the value of G? That's 10. What's the height difference? 10 minus 5.4 is nothing but 4.6 is equal to, what is the value of C? That's given to be 460. And what is the value of delta T? That's exactly what we need to figure out. Therefore, delta T will be 10 into 4.6 is 46. 46 divided by 460 is nothing but 1/10, which is 0.1 degree Celsius. And that's the option B. That's the correct answer. Beautiful. A lot of you got it correct. Excellent. I'm proud of you. And those of you did not get it, no problem. It's okay. You have learned a lot from this question. Okay. Thank you, Gani. You love you too, bacha. Okay. It's not ABCD. Please think carefully. Okay. Don't answer randomly. Okay. Let's get going to the next one. That was answer B. Coming up with the next question. There are two liquids. And there is mass m, specific heat is also given, temperature is also given. Another liquid, different mass, different specific heat and different temperature. So think, what will be the final temperature of the mixture? Standard important question which is high probability question. That means it is very likely that these kind of questions are going to come in the JEE Mains examination. Let's see how many of you can actually get the +4 marks. Because those of you get +4 marks, the ranks will be boosted by 500 to 700 ranks easily. Sometimes even 1000 ranks. Come on, let's see who can get that +1000 ranks at least by solving this question, by gaining that +4 marks. Else you will get -1 marks, guys, if you mark this wrong answer. Come on. Some of you are saying D, some of you are saying A. Okay, come on, all my minion warriors. think carefully, just solve the question, see who lost heat, see who gained heat, that's it. Just think about that. So who is the hotter body, who is the colder body? So hot, cold. So hotter body had a temperature of 2T and colder body had a temperature of T. Hot body has a mass of M, specific heat capacity C. Cold body has a mass of M by 2, specific heat capacity 2C. Okay, come on, think. Now all you need to write down is heat lost by this guy by M is equal to heat gain by M by 2, because that's the colder one, which is at temperature T. Let's assume that their final temperature, mixture's temperature, is T0. Assume it as T0. And now solve the question, guys. Heat lost by M into C, change in temperature. This is higher, this is final. Bigger minus smaller. Lot of people make this mistake. They put a minus sign. Don't put minus sign, guys. Please understand that, because this is what is the heat lost. If, for example, I have 100 rupees. I tell you, I lost 20 rupees. If I say I lost 20 rupees, how many rupees do I have? I have 80 rupees. If you say I lost minus 20 rupees, then that means actually I have gained 20 rupees. So lost minus number means it is actually adding it. So don't put a minus sign. If I lost minus 20, that means my actual number of rupees is 120. So understand the difference. Yeah. So the heat lost magnitude wise, value wise, magnitude wise is MC 2T minus T0. 2T, higher minus lower. High minus low. This is high temperature. This is lower temperature. Always a positive value. And heat gained by the colder one. Mass into C into high minus low. This is higher temperature, this is lower because this was cold body. So that will be T0 minus T. I hope this is clear. Yep. Good morning, Kamadre. Yes, okay. So MC goes away. You can see that MC 2 goes away. And therefore I'll have 2T minus T0 is equal to T0 minus T. So now shift it. So T bring it here, it will become 3T. T0 bring it there, it will become 2T0. So T0 will be 3 by 2T. Let's see how many of you got the answer. Option D was correct. Option D was correct. I hope you guys understood how to solve these kind of questions. Every time people make that mistake, it's always high minus low. Always keep both the terms positive. Think about it logically, na? This is equal to, this is LHS, this is RHS. How can you have a negative number here on the LHS and positive number on the RHS? Doesn't make any sense. If you have a positive number on the RHS, you would have a positive number on the LHS. So make both the terms always positive. Keep this in mind. Clear? Oh? Amazing, go guys. Oh, Roshni, Janki, you are in 8th standard. You are too early. Maybe 3 years early to this channel, but it's okay. Hit the subscribe button. Eventually you will need it. Okay? And I'll be waiting for you, bacha. Okay, that's the answer. Beautiful. Let's get going to the next question coming up on your screen. Let's see whether you can do this. Think, this is also a difficult question for mains. In an experiment, there is a sphere of this many grams. Up to 150 degrees Celsius, it is heated. It is put inside water of this many cc at 27 degrees Celsius inside a calorimeter of water equivalent 0.025 kg. Final temperature is this much. What is the specific heat capacity? Okay, I will explain you the situation because a lot of you might have got confused. What the hell is happening, sir? I didn't understand only. Okay, so see guys, I'll explain this to you. This is that ball, sphere of aluminium. How many kgs? 0.2 kg. Okay, What is the temperature? It is initially 150 degrees Celsius. Okay, that is the steel ball, or sorry, aluminium ball. Okay, now it is put inside water. How much volume of water? 150 cc at 27 degrees Celsius, and water equivalent. Now see guys, when you have water inside a calorimeter, even that vessel, okay, even that vessel itself has some specific heat capacity. There might be a copper vessel, or I don't know, aluminium or iron vessel inside. So that vessel itself has water equivalent, or rather it has specific heat capacity. Now, because the vessel's material and the water's material is different, so what generally is done, you are given this term called as water equivalent. What is the meaning of water equivalent? If you take 0.025 kg of water, if you take 0.025 kg of water, it behaves exactly the same way as that vessel. So the vessel's thermal properties are same as 0.025 kg of water. So you can replace that vessel with this much water and solve the problem. Is that clear? Oh Laksh, no, not seeing that green tree yet. Windows are closed. Okay, an internal joke between two of us. Okay, so guys, I hope you understand that all you have to do is convert that vessel into this many kilos of water. That's the meaning of that. Thank you, Bharni, so much. Okay, so now my point is, how much water do you have totally? How much water do you have totally? Let's think about it. And what's the temperature? It is 27 degrees Celsius. You have 150 cc plus 0.025 kg. Oh, now this is difficult to add. How much is 150 cc water? 150 cc actual water is there, and 0.025 equivalent water is there. 150 cc is 150 grams. 150 cc is nothing but 150 grams. So 150 grams plus there was 0.025 kg. Okay, so 0.025 kg. Okay, so 0.025 kg means 25 grams, guys. This 150 grams plus 25 grams is how many kgs? Think about it. Yes, whatever cc you get, that is exactly grams. Remember, for water, whatever cc you get is always the gram, because the density of water is 1 cc per gram, or 1 gram per cc. So that's why cc is always numerically equal to grams for water. Okay, so how much will be the total answer for this? Come on guys, think about it. Think about it. What will be the final? Yes, it will be 175 grams totally. So it will be 175 grams, which is 0.175 kg. Yes, 0.175 kg. That's the answer for this. Okay, that is the amount of water you have. Okay, now this problem is simple. You take this ball, hot ball, put it inside water. Their final temperature is how much? Their final temperature is 40 degrees Celsius. So who cooled? The ball cooled. Who got heated up? The water got heated up. So my final equation will look something like this. Think about it. Heat lost by, that aluminium, okay, from 150 to 40, okay, 150 to 40 is equal to heat gained, okay, heat gained by water from 27 to how much? 40. That's the common temperature. That's the equation. See if you guys are understanding it. The heat lost by this ball is heat gained by water. That's it. Thank you, Mr. Zerg, so much. Okay. Thank you, Roshni Janki. Welcome. Welcome all the newcomers. Do not forget to hit the subscribe button so that you do not miss any of my classes again. Okay. Yes. Okay. Now, what is the heat lost by aluminium? Which formula will you use? MC delta T. What is the mass? 0.2. Okay, 0.2. What is the value of C? Oh, that is exactly what we need to find out. So put it as an unknown. What is delta T? Remember, high minus low. Always high minus low. So that means 150 minus 40. That's what you will put delta T as. Is equal to heat gained by water. What is the mass of water? I just wrote it down over here. 0.175 kgs. 0.175 kgs. Okay. Next up, into C. What is the specific heat capacity of water? Now people forget this. Specific heat capacity of water is 1 calorie per gram per degree Celsius. 1 calorie per gram per degree Celsius. You need to convert it. You need to convert it into joules because everything is in joules. So be careful about that. Yes, convert it into joules. So think about it. This will be, how much is 1 calorie? I just told you, 4.2 joules. 4.2 joules. Now this is per gram. So per kg. Remember, 1 kg is 1000 grams. 1 kg is 1000 grams. So if it is these many calories per gram, so per kg, won't it be into 1000? Won't it be into 1000? So 4.2 into 1000. Think about it. This will be joules per kg per degree Celsius. This is the value of C. I hope this is clear. Everybody understanding it? So that means you are going to put 4.2 into 10 to the power 3. And the last thing, change in temperature. Higher minus lower. That's it. Now you just need to solve this, guys. It's not that difficult. 150 minus 40 is 110. 110 into 0.2, that point will go away. So it will become 11 into 2. So it will become 22C. 22C will come over here. And this 10 to the power 3, if you take it multiplied by 175, so you will get it 175 multiplied by 4.2 multiplied by 40 minus 27 is 13. Now can you see that there is only one unknown over here, and that is C. Only one unknown. So solving that, you will get the value of C. I think it should come out to be option D out there. Yes. You don't have to convert it into Kelvin because 1 degree Celsius change is 1 Kelvin change. So it will work for both of the terms. So 1 Celsius is 1 Kelvin change in temperature wise. So it doesn't matter out there. Yeah. So that's the answer. Understood? So this was a beautiful problem. I hope many concepts got cleared. Did you guys enjoy this question? Shall we go ahead to the next one? Shall we go ahead to the next one? Yep. Okay, very good. Let's get going. Oops. Okay, now before we go ahead, let me also show you, because a lot of people have a lot of doubts out there. So guys, if you have doubts, you can send it to us on the Vedantu app from morning till night. Yes, you can send screenshots, you can send questions from any book, you can ask us conceptual queries. Any number of questions are appreciated. There is a dedicated subject matter expert team sitting at Vedantu who is just meant to solve only your doubts. From the Vedantu app, take a photo, send the screenshot or the picture of your question or the doubt that you have. You can even give it handwritten also, or you can just type it out and the doubt expert will immediately respond to all your queries. You can chat and you can close all your doubts. You can also ask for hints. Sometimes you don't want to get the solution, you just want the hint for solving the problem. You can ask what is the next step, or you can just get your solution verified. All of this is there in the Vedantu app. So guys, if you're a part of the crash course or if you're a part of the Vedantu Pro subscription, then you are going to get this facility for free of cost, no charges at all. Okay, yes. So let's get going to the next set of questions and equations. Ankit, the next chapter at Pathfinder is current electricity only. Okay. Anishka Jain, what happened to my hair? I took my hair and there was a brown color. Some kids were painting over there, so I accidentally fell down and my head slipped into the that pot containing that brown color. So, and when I got up, then I saw myself in the mirror and then my hair was brown. So, I'm just yeah, with this. Yeah. Okay. So I don't know. I mean, the kids were playing with the colors, so I cannot do anything. Okay. So here is the next set of equations. Conduction. Rate at which the heat flows is K. Thermal conductivity A. Area of cross section delta T by delta X, or change in temperature upon the length. That's what conduction is. Conductive current is resistance. Thermal resistance is length of the rod by K, which is conductivity by area. Okay, that's next thing. And if you have multiple rods in series, then you add the thermal resistances. If they are in parallel, then use the parallel formula, 1 by R1 plus 1 by R2. The class will end after more 15 to 20 minutes to Sheena Miniko. Oh my god. Yes, what a name. Okay, so more 15-20 minutes. Okay, next up, the radiation related formulas. Again, Kirchhoff's law. It says coefficient of absorption is equal to coefficient of emission. Remember, every body emits radiation. Also, that radiation, when it falls on something, it can be absorbed, it can be transmitted, or it can be reflected. And each body will reflect, transmit and absorb by different amounts. So it says coefficient of emission and coefficient of absorption are always equal. Okay, and remember this. Veer Gupta, I'm not ignoring the chat. Oh yeah, current electricity, I think I have already done Veer Gupta, current electricity. I'll be doing one on capacitors in the next week, Veer Gupta, don't worry. Okay, so next up, Wien's displacement law. Remember, the radiation which comes out, there is a maximum wavelength, maximum amount of colors are of a particular wavelength, and that is related to the temperature. So lambda max into temperature is a Wien's displacement constant. Last law, Stefan-Boltzmann law, which is the rate at which heat is emitted, is sigma E A T raised to 4. Sigma is that Stefan's constant, which has a value of 5, 6, 7, 8. If you remember that 5, 6, 7, 8, it will be very easy. It is 5.67 into 10 to the power minus 8. That's the value of sigma. E is emissivity, that will be given to you, is area, T is temperature. And last thing, Newton's law of cooling, rate of cooling is directly proportional to the difference of the temperature of the body and the surroundings. That's what it says. Don't worry if you did not understand much of these formulas. We'll solve problems. Through the problems you will understand all of this. Let's start with the basics of this. Okay, come on. What if you want only doubt facility? Snehal, I feel that just doubt facility will be not useful. You have to practice papers, bacha. You have to solve papers. You have to have assignments. You need to get that material. You need to get that class notes. So, it comes as a package. So, it's not much. I mean, the crash course price is 6,000 rupees. So for 6,000 rupees, you are not only getting doubts, you are also getting test papers, 20 papers with discussions, with classes of 11th and 12th. So I feel you should just go with it. Don't think about it because it's last few days and weeks. So put in your 100% into whatever time is left now. Very good, Adarsh. I'll be seeing you in many of the micro courses, Adarsh, if you have taken the Vedantu Pro Lite. Very good. Okay. So let's see whether you can get the answer. Ankit says B. Beast Boy says C. Sai Kiran says B. Okay. Newton Baba is everywhere. Yes, Asmi, he will be there till 12th standard. Newton Baba ki jai. Newton, oh, by the way, there is a very interesting story about Newton. Newton wanted to do some research on chemistry. Throughout his life, he studied physics and all that. But when he started chemistry, then I think, he started feeling, he developed some diseases and all that, and he fell ill, he fell sick, and then he died eventually. Or else probably you would find Newton Baba in chemistry also. Okay, by the way, you would have done this This is hot summer time, and I'm pretty sure many of you who do not have AC and many of you who do not want to install an AC, they would have sprinkled water on the cloth somewhere and then lie down on the bed. Have you guys done that? It's very nice. Sprinkle water on the bed on a hot summer day and let the wind blow, and then you sleep on it nicely. It's so relaxing, so peaceful, guys. And the reason for that is because water has large latent heat of vaporization. So what happens is that yes, Aryan, Agni, EKLAVYA batch will get doubt solving facility also. There are discussion sessions. So what happens is that when water evaporates, when you sprinkle water, it evaporates. It sucks energy from the surroundings to evaporate. When it sucks energy, what will it do? It will cool it. Because water has large heat of vaporization, that means you need to give it lot of energy to evaporate it. Or rather, when it gets evaporated, it sucks a lot of energy from the surroundings, which ends up cooling the surroundings, and hence the answer is C. Okay, let's go to the next question coming up on your screen. Yes, especially during power cuts. Yep, a lot of you are relating to the scenario I just told you about. Now the question is, there are two rods, and the question is, figure out the temperature at the common junction. Very easy question. I'll spare you reading this question. Simply put, two rods, find the junction temperature. Okay, let's do this. Let's assume the temperature at the junction is X. Okay, do you guys agree that whatever heat will flow through the first rod will also be the heat which will flow through the second rod? Because they are in series, whatever heat will flow through the first rod will also flow through the second rod. This is just like resistors in series. The same current will flow through all the resistors. Ask me, post a comment below. I will definitely reply to all the micro courses that I am conducting. Yes, so guys, I can say the heat flow rate in 1 is equal to heat flow rate in 2. Now what is the formula for heat flow rate? dq by dt is Ka delta T by delta L or delta X. Ka delta T by delta X, that's the formula. So K is K, A is A, temperature difference, high to low. Remember, heat always flows from high temperature towards low temperature. So T1 minus X, be careful, T1 minus X divided by the length of the rod. What is the length of the rod? It is L1 is equal to, is it equal to, let's see, no problem Snehal, it's okay. No need to put minus sign. No need to put minus sign because we are talking about the magnitudes. So heat flow rate magnitude in 1 and 2 are same. So just use it as it is. And the next one, K, A, temperature difference, high to low. So X minus T2 upon the length, which is L2. Just like for spring force, you don't use minus Kx because force of the spring is always opposite to X. Same way, you just are worried about the magnitude, so don't worry about the minus symbol. Yep. Now you can clearly see A will get cancelled and you will get many terms. So you will get K1 T1 by L1 minus K1 X by L1 is equal to K2 X by L2 minus K2 T2 by L2. Okay, this is what you are going to get. Now shift the X terms, okay, shift this term, okay, shift this term and this term together and bring this term and this term together. That's it, you will get the answer there. So it will become K1 T1 by L1, bring that over there. So plus K2 T2 by L2 will be equal to K2 by L2 plus K1 by L1, the whole thing into X. Now when you take LCM, this L1 L2 will get cancelled out. So you are going to get K1 T1 L2 plus K2 T2 L1 is equal to K2 L1 plus K1 L2, the whole thing multiplied by X. Because the denominator anyways L1 L2 and L1 L2, that denominator will anyways get cancelled out. You can see that the denominator will get cancelled out. So the value of X, you will get it from here. Which is the correct answer? Come on, if you are not dyslexic, you'll probably get the answer very quickly. Come on, what is the correct answer out of A, B, C, D? Come on guys, D? Yes, it is D correct. Yep, D is the correct answer. Beautiful, yes. So guys, it just looks confusing. Daravna, like Crime Master Gogo. Yeah, it's just like very scary. Looks scary, but it is not. It's a very simple villain. Just if you solve basic algebra, even if you are adept, even if you know 8th standard algebra, multiplication, division, LCM, solving, that's it, you will get the answer. Okay, so let's get going to the next one. Okay, coming up on your screen, who is Crime Master Gogo? Ankit, you should definitely Google it out later on. Who is Crime Master Gogo? Yes, long time back, the kids who did not sleep, their moms used to tell, "So jao bacha, nahi to Crime Master Gogo aa jayega." Yeah, long time back. Okay. So Veer Gupta, I have conducted a special lecture just on conduction on our channel. Just go to our playlist. Just go to our playlist out here on Enthuse. Okay, and when you go to playlist out here, yep, and there we go. In physics, you'll find it. Yeah, just go to physics playlist. You will see it over here. Heat, thermal physics. So you will see that in detail.
And oil
there
attack
is
your skin
a special
constantly. Want to fight pimples?
So,
then why only
KTG,
so? Switch to
calorimeter,
Calorimeter
thermal
amplified
expansion,
physics.
conduction. You can see that special
And
lecture
we
just on
Enthuse.
conduction. Yes.
And today
one hour
we're
lecture
going to
just
talk
on
about
conduction.
conduction,
Okay.
like the title
Just do that.
suggests. And
Okay, cool guys. Let's get going to the next one. Let's see whether you can answer this. So two vessels. Thank you, Udayan Sharma. Okay. Yes, Chiranjeevi, you're a little bit late, but it's okay. Just join in for the last few questions that we have, and then later on you can watch the replay of the remaining part. Okay. Now two vessels, same thing, same size, same quantity of ice. The ice melts in different times. What is the ratio of the thermal conductivities? Let's see how to do this question. Guys, the way to solve this question is very simple. Think, if it is more conductive, okay, that means it will cool or it will melt quickly. It will be very quick, right? Think about it. More the conductivity, more the the process will be more quicker. In fact, I can say K is inversely proportional to time. Think about it. K is inversely proportional to time. So that means, guys, think about it. The ratio of the thermal conductivities K1 by K2 will be what? Think about it. T2 by T1. What is T2? T2 is 40. And what is T1? It is 20. That means it is 2:1. That's the answer. 2:1. Remember that. The rate of conductivity is inversely proportional to the time. More the conductivity, faster the cooling. That's it. As simple as that. So there is nothing great about this question. A lot of people unnecessarily do random things. 2:1. Let's go to the next question coming up on your screen. Two spheres, same material, different radii, 1 meter and 4 meter. Different temperatures also. What is the rate at which energy will come out of it? What is the rate at which the energy will come out of it? Come on guys, let's see how to solve this question. First, let me write down everything that we know about this. So this radius is 1 meter, this radius is 4 meter, this temperature is 4000 Kelvin, this is 2000 Kelvin. Each of them will radiate heat. Okay, the question is, what is the ratio at which the energy will be radiated? What is the ratio at which energy will be radiated? Think which formula or which law will you use? I think you will use the Stefan's law of radiation. And the Stefan's law of radiation says the rate at which energy is radiated, all right, is equal to the rate at which the energy is radiated is equal to E sigma A T raised to 4. E sigma A T raised to 4. So the question is, find the ratio of the energy radiated by first to that of second. So energy radiated by 1 by energy radiated by 2 will be, E is the same, sigma is also the same. only area and temperature are different. So it will be A1 by A2 into T1 by T2 whole raised to 4. Now what is the ratio of areas? Remember, you have to take the surface area. Now surface area ratio, area is 4 pi r square. 4 pi r square. 4 pi doesn't matter. So it will be R1 by R2 whole square and T1 by T2 whole raised to 4. Area is 4 pi r square. 4 pi will go. Now what is R1 by R2? R1 by R2 is 1 by 4. So 1 by 4 square, and this will be T1 by T2. 4000 by 2000. That's 2:1. That's 2:1 whole raised to 4. Oh, this is 16. That's also 16. This is going to be 1. So hence the answer is 1:1. Hence the answer is 1:1. Yep, that's the answer. Yep. I hope this is clear. Is that clear? Yes, the answer is A. A lot of you got it as D. I don't know why you guys got it as D. That's the wrong answer. Be careful. Yes, the answer is 1:1, guys. Is that clear? Everyone getting getting a clarity on these concepts? These are very simple, but people leave it. So just because you are with me, trust me, you will be able to do these questions in the final examination. So stay with me, attend all these classes live. Only then you will get the benefit of live learning, and always it's fun to interact, fun to participate, fun to attend live classes than the recorded ones. Okay, so that's the answer for the question. Last few questions coming up on your screen, and there we go. Come on. Which of the following do you think, will have the lowest rate of cooling for the same volume? Sphere, cube or disk? Lowest rate of cooling. Don't worry, Sakti, I know it is taking a toll on your mental health because the exams are getting postponed. So that's why we are conducting these classes, so that you are in touch with the JEE syllabus, you do not lose focus and motivation. That's why we are here. Okay, so don't worry, and I'm pretty sure the announcement will happen very soon. Okay, so let's see how to do this question. See guys, the rate of cooling, okay, I can find it like this. The rate at which the energy is emitted, okay, the rate at which energy is emitted is E sigma A T raised to 4. Now this dq is mc dt, change in temperature. Oh, by the way, this is T raised to 4 minus surrounding temperature raised to 4 and all that. Okay, so this dq is mc, change in the temperature, upon dt is equal to E sigma A T raised to 4 minus Ts raised to 4. Now, what is mass? Mass is nothing but density into volume. Mass is density into volume. So just rearrange this. So you will get dt by dt, okay, is equal to E sigma T raised to 4 minus Ts raised to 4. That area was remaining, so I'll put it over here, divided by, now density and C will come over here. Density and C will come over here. This volume, I'll just put it down over here. Now there is a reason why I wrote it like this. See guys, this one is called as the rate of cooling. This is called as the rate of cooling. dt by dt, rate of change of temperature, is called as the rate of cooling. All these terms over here are same or constants for both the things. For all the things, they are constants or they are same. The only thing which is different is this one. But hold on, even this volume is given to be the same. Check it out. Volume is also same. So the only thing different is area. So for a given volume, which has the least area? If you take a volume and you want the least surface area, which has the least surface area? No, it's not disk. Thank you, Radha. It's not a disk, guys, it's a sphere. Yes, a sphere has the least area for a given volume. You should know this fact. If you take a volume, alright, you want to minimize the area, you will make it into a sphere. If you make it flat or anything else, you pull it, stretch it, it will become into some other geometry, area will also increase. Only when you condense it and you make it a sphere, the area is the least. Yes, that's how it is. Yep. Okay, so hence the correct answer will be a sphere. Yep, the correct answer will be a sphere. Yeah, that's the answer. Beautiful. Got you? Okay, very good. Yes, Richa, correct. That's the reason why in surface tension, every liquid will take the shape of a sphere, because surface area of a sphere is least. Correct. Okay, the last question coming up on your screen. Let's see whether all you warriors can crack the last question and nail the final one in the coffin. Come on guys, let's see whether you can do this. Come on, come on, come on. Good morning, Prabhat. Welcome aboard. Hello Akshita Varadarajan, welcome aboard. So you guys are a little bit late, so that next time you do not miss my classes on time and do not miss my live classes, you can do one thing: hit the subscribe button, click the bell icon so that you guys get notified. And guys, to show your love and support, do not forget to smash the like button out there. Hi Joshua, good morning. Yeah, so yeah, please do that. Let's see whether you can do this. Some of you are saying D, some of you are saying A. Again, Kumar Jana Prakash saying D. Hi Dr. Anurag Yadav, welcome. No problem, Prabhat Sharma, it's okay. Very good, Richa, thank you so much. A is 50%, says Ankit. Hello Pujita Patel, good morning guys. This is Shreyas here. Okay, come on, let's see whether you can do this. Now you have to use, it's already given, I mean this also should not be given actually, but they have given you the hint. Wien's displacement law says lambda into temperature is constant. Now that means, T1 by T2 will be lambda 2 by lambda 1. Okay, now which is the first situation? Let's have a look. The maximum energy of thermal radiation from a heat source occurs at a wavelength of this much. So this is lambda 1. Okay, this is lambda 1. So 11 into 10 to the power minus 5. Now when the temperature will be n times, that means this T2 is n times of the temperature of this source will be n times the temperature of another source. Oh, sorry, not this one, my bad. The temperature of this source will be n times the temperature of the other source, for which the maximum wavelength is this much. So for lambda 2 is how much? It is 5.5 into 10 to the power minus 5. That's what you need to interpret it carefully, because or else you'll get the wrong answer. So guys, you can clearly see now from this what will be the answer. This is nothing but 1:2, and T2 will get cancelled. You will just get n. So n will be nothing but 1/2, and hence option A will be correct. So read it carefully. Yep, 1:2. Yeah, lot of people get 2 as the answer because they fail to understand that T1 is n times of T2. It's clearly mentioned the temperature of this source. Which source? This source over here, this heat source, is n times the temperature of another source. So T1 is n times the other source. That's what people fail to understand. So that's why they get the wrong answer. Okay, so that's the correct answer. Beautiful, option A was correct. So guys, remember, all the students of 2021 who are going to write the examination this year, remember, our crash course has just started few days back. So please check it out, because you're going to get the replays of all the sessions any number of times till the last attempt with the PDF notes, and you are going to have teachers just like me who are going to complete the entire 11th standard and the 12th standard syllabus with problem solving, and you are also going to get doubts from morning till evening. You can ask any number of doubts, unlimited number of doubts from morning till evening, and these test series will come with discussion and reports and everything. You can give these tests as per your convenience. All of this at a very affordable price of just 6,000 rupees. Usually the price was 10,000, but right now the price is only 6,000 when you use this coupon code SHCC. So my advice is, please join it right now, because the course has just started 2 days back and it will be approximately for 1 month. So this is, before your next JEE Mains attempt, okay, before your next JEE attempt, this course will be completed and you will be fully prepared, and this is your last chance to actually boost your performance. Even if your percentile boosts by even 10% or even 5%, I feel it's a big thing. And maybe if you are in 60s range or 40s range, I'm pretty sure it will boost by 40-50%. There is a very good chance, and people have done it by the crash course. So do check out the link which is there in the description box below. Okay, thank you guys very much for joining in. Do not forget to hit the like button and the subscribe button out there. Now the next session is going to be tonight, mock test at 7:30. So mock test at 7:30. Tomorrow is the session for 11th standard, and Saturday 7:30, a very special session for all of you. So guys, I usually come at 7:30 in the night and in the morning at 9 o'clock on Tuesdays and Thursdays. So that's my usual time. Bye bye guys. Thank you very much. Bye bye Frederick. Bye bye Chaitanya. Bye bye Prabhat. Take care. So the meaning of SHCC, that's my initial and crash course. CC stands for the crash course. Okay, cool. Chalo. Bye bye guys. Hasta la vista. This was Shreyas here.